All right. So what we'll do here is, we'll expand upon the knowledge that we gained till now on a standalone mode and try to build up a pseudo distributed mode, which is a single node cluster. Okay, a single node cluster. Now, the single node cluster is what? A single node cluster is the example that we're talking about. So we have all the components installed on a single machine. That's what we'll be building up. And because it's a single server, it is called as a pseudo distributed mode. Okay. Normally, what is a distributed mode? A distributed mode is having your application running across multiple servers. But because we are doing on one server, we are calling it as a pseudo distributed mode. Now, to start with, what we need to do, you download, extract, then set up your bash RC. Now then, the third step 4 is edit the conf files, configuration files, and add a few properties. Okay. Step 5 will be, once you add the configuration properties, the first thing you need to do is format the cluster. Okay. Step 6 is, what we'll do for step 6, we will do, step 6 is create a directory on the Hadoop cluster, and step 7 will process a sample file. Okay, this is called as a word count, right? The processing is called as what? The processing is called as word count. The processing is called as a map reduce. We'll do a word count here, or we can do any other programming also. Create a directory and add files on Hadoop cluster. So this is called what? This is storage. This is storage and this is processing, right? Your HDFS, storage, HDFS, and your processing is what we'll be doing, which is map reduce. Okay, so this will be what our objective is. Okay, for today. I know it's new for everyone, but if you concentrate a little bit, it will be easier to understand. But again, you need to do some practice, so which I will guide you in how to implement it. Now, come back to your location where you have your Hadoop installed. So you're going inside your Hadoop directory. Okay, so go inside the Hadoop directory. In this, I told you, in the bin we have already seen. Your Hadoop command which you are actually running is being picked from your bin directory, right? If I type Hadoop version, it should indicate to me which version of Hadoop I have installed. Okay, this is coming from the bin directory. Now here you see there is a config directory also. Okay, there is a config directory. If I go inside this config directory and do an ls here, there are some important XML files. Almost all the files are XML files here, apart from one which is a Hadoop env.sh file. Now the core important files for me to understand here is, okay, some of the important configuration files for me are, okay, core site XML. Okay, let's do enter. Yeah, core site XML, HDFS site XML, mapred site XML, slaves file, masters file, and there is a Hadoop env.sh file. Now these are your important XML files which is very, very important for you to understand. Okay. Now what does these files do? These files are, what is a core site XML? Core site XML contains properties relevant to entire Hadoop. That is, what is entire Hadoop? HDFS plus MapReduce, right? Your HDFS plus MapReduce, which is nothing but your processing, your storage plus processing. So core site XML is an XML file which contains properties relevant to your entire Hadoop. Okay. So next one is HDFS site XML. What is a HDFS site XML? As the name says, HDFS site XML contains properties relevant to HDFS. Okay, my name node, my data node, my block size, my replication vector, all this will go inside my HDFS site XML. Then there is a maplet site XML which contains properties relevant to your MapReduce. Okay, a slaves file will be there. Slaves file contains a list of servers that will run as slaves. Okay, masters contains a list of servers which will run as secondary name node. This I have not introduced to you. Secondary name node I have not yet introduced you. We'll talk about it today or tomorrow when we do the actual installation. Okay, and then there is a Hadoop env.sh file contains environmental variables that are loaded by Hadoop executables. Okay, so these are the XML files, or these are the important files which are very, very important when you are actually setting up any cluster. And these files should be on your fingertips. Okay, when I say on your fingertips, people will ask you a lot of questions on these XML files. What does these files contain? What is the importance of each of the file? Right? What is the importance of each of the file? If I want to make a property change, where do I go and make the property change? How do I edit the change and all? Right? So those are very, very important, and you need to understand those XML files as well as what contains what properties go inside each of those. Okay. So guys, you are following me, right? Yes, no. Okay, I have these properties. I'm just trying to pick them up. This is okay. I have these properties from here which I can pick it up. Okay, all right. Now before we edit, before we make any changes in here, okay, before we miss any changes in here, let's open the first file. VI. How do you open the file? If I want to edit a file, how do I go and open the file? I do a VI core site XML. Now you see here, as it is in the standalone mode, there is nothing in the configuration. Okay, it's like an XML. Okay, it's an XML file, so your XML structure is followed, and there is a configurations, right? Your configuration is all in between these two configuration tags, similar to your XML format. Now you have an open tag and you have a close tag. So your open configuration and there is a close configuration. Now one important property that I will put in here is, okay, a property that we will go inside here is, which will indicate where the default file system is going to run. Okay, so this is a property start, the end of the property, and there is a name of the property. The name of the property is fs.default.name and the value for that. So this is how the property syntax is. So you have a property that is a name and then there is a value for the name. Now the name of the property is fs.default.name. Okay, fs.default.name, and the value is hdfs ::. You can basically go with, if you don't have an IP address, so I would say, let's say, type in localhost. Okay, localhost, and save this file. And there's a port number here which we'll talk about later. Okay, so there's a port number which says 8020. I will save this file. Normally, if I give the host name, the host name should be localhost.local domain. But even if I say ping of localhost, it should work. Okay, because your DNS entries, or sorry, not the DNS entries, there's an etc file. Okay, there is an etc host file which will basically contain these entries, which will come to that in a short while. Now, once my core site XML is done, the next XML file is my HDFS site XML. Okay, the HDFS site XML contains some properties. HDFS site XML should contain some properties. These properties are relevant to your HDFS. Now, what is the first property I will do here? I will enter three properties in total over here. Copy this. Okay, so now look at these properties. What this property talks about is, this is one property, this is my second property, and this is my third property. What this property talks about is, okay, dfs.name.dir. That means this is relevant to my name node, and this is where my metadata will be stored. Okay, the name node's metadata is going to be stored. Now, what is metadata and all, I have not explained to you. We'll come back to that and explain to you in detail. We'll talk about that once we set up the cluster. We'll go through those topics in a short while, or maybe in tomorrow's session. Okay, now this is my name node metadata. Then there is a property dfs.data.dir, which is indicating to my data node. Okay, and there is a replication factor. Because I am building a single node cluster, all the processes will be running on a single machine. I'll have only one server. My replication factor will also be 1. Because if I say 2, and if there is only one server, there is no way you can actually put your replication, right? So you will go with a single replication. If I don't specify this replication here, what will happen? It will apply a default replication of 3. And we don't want a default replication of 3 to be applied here. I want a single replication to be applicable. Okay, now this is what I have created, I have set up. Now, this directory structure, which is a value, okay, I have not yet set, right? So this directory structure has to be created. So let me quickly toggle this. Name node, and this will be my data node. Okay, so let's create the directory structure. Save this file. Now, because I have a big directory structure, I can directly do mkdir-p. Okay, this will actually create the entire directory structure in one go, because it has got multiple folders within that. Now, the second one is mkdir-p. It will be a data node, which is relevant to my data node. Okay, if you want to verify this, just do Hadoop_store HDFS name node. Okay, it is a blank, it is an empty directory which has been created. Now, one important change you need to make sure is the permissions on the data node directory should be 755. So how do you change the permissions? chmodify 755 for my data node directory. Okay, even this one will also be empty. The data node directory will also be empty. All right. Now, I did modify my core site XML. which is what the core site XML contains properties relevant to your core site, I mean your entire Hadoop. These are my core site XML properties. Oops, what happened? Okay, then my HDFS site XML. In my HDFS site XML, I have put 3 properties. One is for name node, the second one is for data node, and the third one is for replication factor. Okay, 3 properties. And finally, my XML file, my last XML file would be my MapRed site XML file. Even the MapRed site XML file is empty. When you initially download, there's nothing in here. Now what will I do? I will update the MapRed site XML, indicate to this MapRed site XML where my MapRed has to run. Now the MapRed is something which I have not introduced to you till now. I mean it becomes more confusing if we talk about it. Tomorrow we'll talk about MapReduce. What happened? So similar to the name node, which is a master, you call the the master component of processing as the job tracker. So this is the property which is indicating where my job tracker should be running. So as I did with previous with the name node core site XML, I can remove this and insert local host. Okay, and save this file. Save this file. Now this is what is contained in MapRed site XML. Let me copy and put it in our notes. Now the next one is my slaves file, which is localhost. Okay, slaves file is indicating localhost is what? On the same host. So because we are doing a pseudo distributed mode, that means every process will be running on the same host. So I will leave it as localhost there only. Then okay, so you have the next file that we have is masters file. Masters files will also contain localhost, so I'm not changing anything. All defaults is what I'm adhering to. No changes. One change I might probably do is in my Hadoop env.sh file. Okay, there's one property which you need to worry about, which is Java_home. The Java_home is something, a property which is already, which is right now is commented out. That means it's not set properly. So we will add this property here. Export Java_home equals. Where do we have the Java home? I think I copied it here. So because this is important, mandatory, because all the processes which start from here will be picking up this Java home path. Okay. Now once this is done, we are all good. We can start the processes. Right. Now before I start the process, I need to ensure I will format my cluster. Okay. Now before I start the process, I need to format the cluster, right? So typically when you procure a new hardware or when you purchase a new hard disk, what is the first thing you do? You will definitely go and format the cluster, right? Format your hard disk or your machine, right? It should be writable. So what will a format do? A format will do lots of changes, like say creating the directory structure, creating inode tables. All those entries will be created. In the same way, we need to do a format for our Hadoop cluster also. Now, how do I format the cluster? So because I'm new here, I don't know what commands I can use. I will type in Hadoop first. Okay, Hadoop. Then I can see the first command I will see here is Hadoop name node minus format. Okay, so I will type the same thing, Hadoop name node minus format, and type enter. Now it is indicating, okay, it is telling you, should we reformat the file system? Where is the file system? This is the file system. If you remember, we did this in our HDFS.xml. Say yes. And towards the end, towards the bottom, you should see a message which is indicating the name node directory has been, or the storage directory which we have set up for the name dfs.name.dar has been successfully formatted. So unless you see a successfully formatted, you cannot proceed forward. Don't proceed forward. Okay. Now, an important thing that I want you guys to explore is there is something called as a passwordless SSH. Okay, there's something called as a passwordless SSH. How do you set up a passwordless SSH is something which I want you guys to explore today. So tomorrow I will show you. So this is the format the cluster is what we have done. So Hadoop, how do I format the cluster? Hadoop name node hyphen format. Okay, once I format the cluster, I need to start the step 6 is start the processes, and this will become my step 7. Step 8 is we'll process a sample file, right? So let's start this. Step 7, step 8. Now before I start, how do I start my cluster? Now you go inside this location in the bin directory. Okay, in the bin directory when I was showing you, there are a lot of executables. Now here I have a start all.sh. Okay, a start all.sh. Now what is a start all.sh? The start all.sh will start now every process, right? Everything that we talked about HDFS, we talked about MapReduce. So HDFS will have a master process and a slave process. In the same way, for the MapReduce also, you have a master process and a slave process. So what we are trying to do right now, we are trying to start my cluster, but we will encounter some issues here. Let's see what those issues are. Start hyphen all.sh. So it's starting my name node. For the first time you're doing it, say yes here, and it is prompting me to enter the password. Okay, if I don't enter the password, it will wait there indefinitely. So I have to keep on typing in the password. Then it's starting with the data node. It is asking me to enter the password. Now it's starting the secondary name node, and then it's starting the job tracker, still asking me to enter the password. Okay, and you have everything started now. Okay, you have everything started. It says everything is started. So if I do a ps-ef grep for Java, I will see multiple processes have started. What process is this? This process is my name node. Then I have a data node here. Then I have a secondary name node. Then my job tracker, and there is a task tracker, which are my slave components. So don't worry about these components and all. We'll come back to that. Okay. Now it's saying that my cluster is started. Okay, my cluster is started. How do I verify? To verify your cluster, you basically go inside your web browser. So it's a 10.1.100. So it's not coming up. So there's one thing which we need to do. We need to probably disable the this one slight change which we have to do. There's most probably a firewall might be up and running, so we just need to disable the firewall. So I have these commands already here. Come on. Yeah, so this is something which you guys will also encounter. So as a root user, I need to log in. System firewall D, stop the firewall and just verify the status once. Okay, so it says the firewall is starting. It should be stopped. Disable. Stop the firewall. One second, guys. It's still not stopping for some reason. I think it's automatically starting. Let's try to quickly access this. Okay, there you go. So this is my GUI. Okay, from my GUI, how did I access my GUI? So I think you cannot see what I'm typing here. So what you will do here is you take your IP address, ifconfig. Okay, you take the IP address which is 10.01.100 and type into the browser window 10.01.100 colon 50070. Okay, so this will tell me this is my GUI, okay, admin interface, my name node GUI admin interface, which gives me some information, okay, which is indicating what is my cluster summary. Okay, how many live nodes are there? What is the DFS? DFS is a distributed file system. What is the configured capacity? Now all this information you can actually look at from GUI as well as from CLI also. From the CLI, if I want to look at, what I will do, I will type in Hadoop FS, or you can have Hadoop. So for Hadoop, there is a DFS admin command, which is similar to your admin client. Okay, so you type in Hadoop DFS admin -report. Okay, so this command will tell you, okay, what is the configured capacity, what is the DFS remaining, what is the present capacity, how many data nodes are available. All this information which you can see from your GUI can also be seen from this command line. Okay, so that is how you build up a cluster, and that's what we have done till now. We build a cluster of a single node. We have built a single node cluster. Now let me update something here. So start the processes. You format, start the processes. Step 7 is disable firewall on the OS. So how do you disable the firewall? You can simply use these 3 commands. Okay. Now once my firewall is disabled, that firewall is disabled because we want to access it from outside the server, right? We want to access the GUI from outside the server. Now once that is done, I will go and execute my Hadoop commands. Hadoop fs-ls. Now it says no such file or directory found, so I will need to give / here. Now you see the difference here. This command which I am running, which is Hadoop fs-ls, this is the command which I am running on my cluster. If you see the difference here, if I say ls-l or ls-l of /, it gives me a lot of output. So there's a major difference here. The difference you need to understand, what is ls-l and what is Hadoop fs-ls. What is the primary difference between these two? Okay, this is what you need to understand. So this ls-l is at my Linux prompt, is at the Linux level. Hadoop, if you are executing any Hadoop commands, you will precede that command with Hadoop fs. Okay, you will precede that command with Hadoop fs command, which will actually execute as a Hadoop command. So see, the output is the same. Okay, the output can be same. If I run my ls-l on my /root, okay, on my /, it is giving me an output of all these details. Similarly, if I do a Hadoop fs minus ls, I'm getting only temp directory has been created. So there will be a temporary directory which gets created automatically whenever there is a new cluster setup. Now, moving further, okay, I want to create a directory and run some sample program right now. So I want to show you, like say, build a cluster and run a sample program. What do you do? Right, first thing is you need to, so the example that we talked about yesterday and day before yesterday, first thing that we need to do is we need to store the data and then we process the data, right? The same thing we are going to do now. First thing is we will store the data and then we will process the data. For me to store the data, okay, I will need one text file. Let's say I'm creating one text file, okay, test.txt. It has got some content in this. This is a new file to, or just say this is a test file. This is a test file to test my Hadoop skills. Okay, so what all do I have here? I have, this is a test file to test my Hadoop skills. So some amount of data I'm actually loading in here. What I will do is, maybe I'll populate the same file, maybe say, so the same file, the same line has been pasted in 10,000 times. Okay, I have pasted the same line 10,000 times so that I have a huge data set. All right, so I'll have a huge data set. Okay, I'll have a huge data set. Now my objective is, to find out how many times each of the word in this text file is existing. So if I say cat test.txt, so this is occurring how many times? Because it's a 1,000 liner, it should be existing 1,000 times. Is 1,000 times, a 1,000 times, test, because there are two tests, test here as well as test here. So it should come, the output should come as 2,000 times, file is 1,000 times, to is 1,000 times, my is 1,000 times, Hadoop is 1,000 times, skills is 1,000 times. So that's what the final outcome should be. Okay, that's what the final outcome. Let's see how Hadoop will achieve that final outcome. Okay, how Hadoop is going to achieve. Because you are learning here, what I would suggest is go inside your Hadoop install location. Within that, you will have a Hadoop examples jar file. Okay, this example jar file has all the, there are a lot of programs built into it. Now, how do you execute a jar file? You will need to type in Hadoop jar, Hadoop examples.jar. So now this is a jar file, it's an archive file which has got some valid programs in that. Now, out of which, what we are interested is, we are trying to figure out the word count. A word count is what? It is a MapReduce program that counts the words in the input files. Okay, so the input file is what? My test.txt, which I will obviously need to upload into my Hadoop cluster. So first thing is, before I can run this program, I need to first load the data, right? What we talked till now is, people will collect the data, load it into Hadoop cluster, and then process the data. The same thing is what we are applying here. We are loading the data. We have collected the data. We are loading the data from your local file system into your Hadoop cluster. So how do you do that? First thing is, I need to create a directory structure. Hadoop fs-mkdir / let's say I'm creating an input directory. Okay. Once the input directory is created, okay, I will need to load this test.txt into the input directory. So how do I verify? Hadoop fs-ls / if I verify if my input is created properly or not. So my input directory has been created. I know the input directory is there. So now I can populate this input directory. Hadoop fs-put. So now, again, as you are learning, so there are a lot of commands which are available. Since I am new, if you say you are new, just type in the command and then what parameter it has to take, it will give you automatically. Okay, so what we did till now, we did a ls, okay, and we did a mkdir, right? So mkdir is also picked up from here. Now, once the file is created, once you have the folder created, we'll upload the file. How do I upload the file? I need to type in Hadoop fs. Okay, there is a put command. So there is a put command here, hyphen put. What is it I'm uploading? Test.txt into where? Into input directory. Now my file has been loaded. It says, I did not get any error message. It just says, it just comes out, the prompt, it comes back to the prompt. Now let's verify if the file is being loaded into your Hadoop. Hadoop fs-ls/input. Okay, there you go. You have a test.txt. Now even further to verify, if you want the file is the same thing, you can do Hadoop fs-cat input/test.txt. So this is the exact content. Now this command, okay, this content came from where? This content came from your HDFS. Okay, so this command which I gave, Hadoop fs-cat, came from your HDFS. You can also do cat of test.txt, and this cat of test.txt is coming from where? This is coming from the file system itself. Okay, on the local file system. Okay, now we loaded the file. The next thing is executing the program, right? How do I execute the program is what is important. So Hadoop jar, Hadoop examples .jar file. I'm calling word count explicitly, word count on where the input is, the input directory input/test.txt, and the output, maybe I'm passing it to my output directory. So a job has been launched right now, okay, which is a MapReduce program. So map and reduce is happening. So this map is 100% complete. So reduce is starting now. Now once the reduce is also complete, it should indicate your program is complete. Okay. Okay, so the program is complete now. It says job complete successfully. This job is completed successfully. Now if I want to see the verified my output, where will I have my output? My output I already given the destination location, Hadoop fs-ls/output. Why is that? Okay. Oh, I think I missed out. So it's saying it's got as output. So let's try to use that. So Hadoop fs-ls. Now within this directory, okay, on my HDFS layer, I have a success, I have a logs directory, and I have a part-r-000. Now where is my output? It says success, but where is the output? The output is contained in Hadoop fs-cat. Copy and paste this. Now this gives me the alphabetical listing of all the words and how many times each of the word is occurring in my test.txt file. So I have run a simple MapReduce program. Now this is telling me it's an alphabetical order, and in ASCII, uppercase takes the precedence than the lowercase. That's why uppercase T is here. Okay, so this is what we have done now. We have set up a multi-node, we have set up a single node cluster. Okay, started the processes, loaded one small file, created a small file, uploaded into the cluster, okay, and ran a MapReduce program. Right? So this is what we have learned till now. Create a directory structure and add files to Hadoop cluster. What we did, we added one file and we ran a MapReduce program. Any questions so far, guys? Okay, if no questions coming in, then I think perfect. So the assignment for you guys is build up this multi-node, a single node cluster by tomorrow. Okay, and try to start all the processes. I mean, I'm going to share this recording later, so you should have a practice around on this. Okay, I'll share the video as soon as it is available, and maybe you can take time to set up a single node instance. I don't want anything, just set up a single node instance and show me on your machine how you set it up, and the GUI admin node. Okay, I would say GUI admin interface.